working code of the website. Over here, the entire working code has been segregated into three different folders: backend, front end, and the load balancer. The backend of this program of this code has been built using Golang, which is a robust backend language. It has been particularly used to leverage its properties, its concurrency properties, and also because Golang is a language which runs super fast as compared to the other backend languages which are practically in use max of the times in the market, that is Express and Next.js backends. So yeah, building a Golang backend makes your application not only robust but at the same time it also provides a lot more functionalities and a lot more speed to your backend than that of the traditional backends that are in use. So I would quickly give you a thorough look out of the code on the website. This is the main.go file. This is practically the heart of the backend portion. It bundles all of the backend code in one file and delivers it to the front end. These are the models that I have built for the website. This is the user model for custom login into the website. When the user is logging into the website, there are two ways the user can log in into the website. One way is using the Google Auth client or the OAuth thing, which I've implemented using Next.js. If the user doesn't want to log in with his Google ID, the user can make a custom login, and in that case, the user needs to fill out an entire form consisting of his details, personal details, his email ID, and stuff. So yeah, that portion has been implemented in this thing. And then there is an itinerary models. These are the models for creating the itinerary, which I've already displayed in the earlier video. And this is the model for creating the post, like the for the Notion, like the Notion kind of thing, which I've shown in the earlier website. So yeah, this has also been shown. And over here are the respective controllers. This is the user controllers, and all of these controllers are listed over here, like for the get user, registering the user, updating the user, deleting the user. Of course, the user doesn't sometimes it happens the user doesn't want to keep his account or her account, so I've also kept an option for that. List users is basically not implemented in the website. This is practically for the developer to view how many of his users are logged on into his website. Change the user role, and finally get a user profile. This is only applicable if the user like dynamically creates his website and not dynamically creates his own sign up thing and not Google logs in. If the user is using his Google ID to log in into the website, it's basically will show only his Google ID, email, and basic informations which has been rendered directly from Google. Okay. Finally, this is the database portion of the website. The database that I've used in the backend portion is the MongoDB. I have used MongoDB, a NoSQL database in this case. This is because I think uh, MongoDB is a very powerful kind of database, which I practically seemed necessary for this kind of travel application. Using a SQL database and querying multiple times into the database to just generate your travel itineraries and then fetching your travel itineraries would have been practically costly. So yeah, I went with MongoDB. These are helper files. This basically helps your controllers to check certain times or match certain things to their hashes and stuff. These are middlewares, coarse middleware. This practically allows your front end to connect to the back end portion of the website, and also allows and also like prevents other kinds of front ends or other malicious front ends to connect to your back end. So coarse is practically necessary in any kind of website. 3000 is the URL or the origin like env.env for the .env URL for the front end server. So yeah, and then there are the routes over here. I have like the middlewares are called over here to display the final routes, and these routes are then like rendered into the main.go file. To this is practically the heart of the website. From here, the entire backend is like called onto the website. And then there is a load balancer portion of the website. This basically connects the front end and the back end server and practically divides the load evenly in between the front end and the back end servers, so that in peak seasons the website doesn't crash and the user gets a smooth UI UX experience, which is the primary feature and the primary motive of this website. Next on, there is the front end portion of this website. Okay, and already I have shown you the entire front end portion of the website and the earlier video. So yeah, this is basically the entire front end portion of this website. All the components have been kept over here, all the assets over here, app things, auth, dashboard, editor, marketing, product, and stuff. So yeah, all the codes have been properly segregated into different folders to keep it a clean code. And lastly, the entire thing has been dockerized, and I've also created a make file for it. So if you like wanna run this thing locally onto your system, all you need to have is Postgres 16 image on your Docker, and after that you need to type out the command make, and this is gonna create a Postgres 16 container, and then you need to type out the command npx prisma db push, and after that it's gonna push your db database into the container and npm runtime, and you can run your entire website. So yeah, another important thing that I've forgot to mention is that I have used a second database in this front end portion of the website. This is the PostgreSQL database. I've used two databases to like keep things in sync and not particularly put pressure on one database, so that querying from the database multiple times becomes expensive. Both the databases are again kept in sync using the load balancer, the MongoDB portion of the website which has been implemented in the backend section of the website, and the Postgres portion of the website which has been implemented in the front end section of the website. Both of the databases are kept in sync and in proper working condition with each other, and the entire app is Dockerized. So yeah, there's that. This is the entire workflow of the app. So basically there is a backend server, there is a front end server. In between both of them there is a load balancer which evenly loads out the traffic between both of the servers. There is also two-way backend over here. One backend has been implemented in the there is also two-way database system over here. One of the database is has been implemented in the backend portion of the website, and one of the database has been implemented in the front end portion of the website, MongoDB and PostgreSQL respectively. Both of these databases are also kept in complete sync with each other using the load balancer. And yeah, so this is basically the entire working code of the website. The entire code has also been pushed onto the GitHub, and I will be sharing the GitHub link with you. Thank you.